All right, you knew this was coming. What if we have to solve a totally radical equation where there's two radicals? Okay, let's do this. Again, why don't you pause the video and take a moment and think to yourself, what would you do given this situation? And then in a second, come back and I'll tell you my thoughts. Okay, you guys ready? I think we have several options, but I think the bottom line is no matter what, we're going to be forced to square both sides. The question is there a way that we could rearrange things to make the squaring the easiest possible? And in this case, there's not too many options. I could subtract 1 from both sides and then square this side. I think I'm just going to go ahead and leave it as it is and square the right-hand side and then square the square the left-hand side and then square the right-hand side of the equation. And now that I've done that, let's go ahead and the right-hand side is going to be easy. The left-hand side, you're going to love this. We're going to FOIL. So it's to make it so that you do this correctly, it's probably best if we actually write it all out. I know it would be so nice to save ourselves this hassle and not have to write this out, but honestly, it's just going to be so much easier to visualize what needs to be done, and probably fewer mistakes. On the right-hand side, it's just 3 minus x, so yay, that's beautiful. Okay, now on the left, square root of x plus 2 times square root of x plus 2, that is lovely. It is simply x plus 2. And then 1 times square root x plus 2 plus 1 times square root x plus 2, that gets us plus 2 square root of x plus 2. So that's kind of the least fun part of this. And then 1 times 1 gets us 1. And then we still have 3 minus x. All right, let's keep it going. So the next thing is we'll try to get the radical by itself, and let's go ahead and get the x, get everything to the other side. So it'll be 2 times square root of x plus 2, and I'm going to subtract x, so that'll leave me with a negative 2x on the right hand side. And then this is 2 plus 2 plus 1, that's 5. I'll subtract 5 from both sides, so that gets me minus 2, 3 minus the 5 over here. Oh, I'm sorry, it's only 2 plus 1. This 2 is out in front, so it's 3. So, the numbers just go away. So now we'll divide both sides by 2 to get the radical by itself. So we go, let me go ahead and get a different color in here. Let's try this. Divide by 2, divide by 2. That gets us square root of x plus 2 equals negative x. And then again, we're forced to do a square. We have no choice. We're not going to get rid of that radical without it. So I'm going to go ahead and we will square the left side and square the right side. And when we do, we get x plus 2 on the left. Yay, that was easy. And on the right, we get a positive x squared. And then finally, to finish this baby off, we're going to have to do what we did a minute ago with the other types of equations. We'll make this into a quadratic and try to solve if possible. This will be 0 equals x squared minus x minus 2. And if we're lucky, we should be able to do x factor on that, and I don't know if we're going to get lucky on this or not. Maybe 2 and 1 and negative. Hey, it looks like that actually might work. Yay! Okay, so I think it's going to be x minus 2 times x plus 1 equals 0. And I'm going to remind you guys something to think about. When you're in a situation like this, I want to remind you that after you do all this fancy work, you might want to just, in your head at least, FOIL these guys and make sure that it actually is that. We get x squared minus 2x plus 1x, that's minus x, minus 2 times 1, that's minus 2. Okay, good, it works out. Okay, and then our solutions are x equals 2 and negative 1, and we'll just double check and make sure that these guys aren't extraneous. Let's see here, 3 minus 2 and 3 minus negative 1, that's all cool. And then let's see here, negative 1, that'll be positive, and 2, that'll be a positive. So everything looks pretty good. I think I'm okay with that. I don't think I'm going to have to worry. If we wanted to, we could actually go through and do the math, but at a bare min, I'd like to check and make sure that my radicands do not become negative. And in this case, they did not. So yay, yippee, we have solved totally radical equations when there's two radicals.